Hi everyone, I am Siva Prasad, working as an associate professor in CSE department, Guntur Engineering College. In this session, we are going to discuss about achieving qualities in SADP, software architecture and design pattern. So what is software architecture and what are the quality attributes? Already we have studied. So architecture is the critical relation for many quality interest in the system. So architecture lays the foundation for the qualities in the software. So that means architecture plays very important role in acquiring the quality of the system. But remember one thing, quality is not entirely depending upon only on architecture. Along with architecture, quality is also depending upon other activities. But architecture gives the foundation of the quality. So we need to play very important role. Sorry, the quality architecture plays a very important role in acquiring or achieving the quality. If we have not paid sufficient attention at the time of architecture, so there is a chance of losing the quality. So very interestingly, almost all the developers are focusing on the quality attributes at the time of architectural phase, achieving the quality. So there are some quality attributes, and there are some techniques or tactics to achieve this quality. These are introducing the tactics, availability tactics, modifiability tactics, performance tactics, security tactics, testability tactics, usability tactics, and relationship of tactics to achieve the patterns. So immediately you will get some idea as these tactics are nothing but the quality attributes. In the quality attributes we have discussed 6 quality attributes, but here we have 8 tactics. What are the additional tactics? Introduction tactics and relationship of tactics to architectural pattern. Okay. So introduction tactics. So the introduction tactics at the time of introducing the system, at the time of beginning of the system, the architect needs to have much more focus on the quality attributes. So the to control the quality of the software, the designer or the architect has to focus much more on the quality attribute at the beginning. That means introductory in the sense what quality features they want to have. They must have clear idea. They accordingly they prepare their tactics. Tactics means already you know the meaning. So generally use the word tactic to handle the things. These tactics are not any theories. They got these tactics by practice, number of years. Experience pays off. So don't think that the experience only from you, but you can gain the experience from others also by seeing, by observing. You can get some practice. Okay, the quality attributes. So they prepare some stimulus and tactics, the control to respond this stimulus, and you get some response. So introductory tactics, so there are so many introductory tactics like capture code, scramble code. This also comes under tactics. Okay, next, availability tactics. Availability means whatever the services the system has to offer, it has to offer without any interruption, without any hazardous. Whatever the services the user is expecting from the system has to be offered without any interruption. You call it as availability. So for this availability, one tactics is offering the redundancy. Redundancy means duplication of the element. You call it as redundancy. For example, you consider power availability. So when you are making any, so for example, you are writing online exams, you are working with your normal PC, so there is a chance of power failure. So what you want, so immediately you will offer some UPS. Whenever power fails, automatically UPS get on. UPS stands for uninterrupted power service. Automatically whenever the power fails, automatically UPS gets switched on. So you are able to use the power continuously. That means power service is available continuously. So because we have maintained one redundancy, one duplication of the device for power supply. So in the you see, first you need to identify the possible fault, and then you need to make some controls. You need to make some controls to make the availability, and then you fault masked or repair made. That is the availability techniques. For example, already we have discussed in the power availability. So what is the in the power availability, what is the problem? There is a chance of power cut, there is a chance of voltage fluctuation. So you have arranged some controls. There may be UPS or maybe some other systems like that you have arranged. So that fault is masked. That means you came out of that problem. So in the same way, you consider the hospitals. So fault. So in the availability, we follow 4 sub-steps. First sub-step is fault detection. Second one is recovery and preparation and repair for that fault. Third one is recovery reintroduction. Fourth one is prevention. First, they need to identify what are the possible faults, what are the possible errors, defects, ping, echo. For example, you consider the health system of a person. So you ping at the heartbeat. So they identify what are the possible problems. So whenever you went to a doctor, so immediately they will check the heartbeat as well as pulse. So why they trying? They are trying to identify the faults. That means fault detection. Once you are able to find the fault exactly, then only you are able to you are able to solve the problem in the exact manner. If you are unable to find the fault exactly, definitely you will not get the solution. So that's why in the availability, fault detection plays vital role. So the architect make all the things to find the exact fault. Once you find the fault exactly, then you plan for recovery preparation and repair. How to come out of that fault. As you know the fault, then next step is to what are the various methods to come out from that fault. You call it as recovery preparation, voting, active redundancy, passive redundancy, spare parts, like that they follow something. Actually in the power example I have given, UPS is a redundancy. Next one, recovery reintroduction. So you see which recovery or what combination of recovery mechanism is better to give the more availability. We say shadow or resynchronization or rollback situations. Next one is prevention. So you know the meaning, prevention is better than cure. In this way, they try to remove the possible errors first. Next, after that, there is a chance of problems. Then we come from the fault detection. So you need to find the possible removal of the errors from the system. Transaction processing monitor. At last, you will get the fault masked or fault proof system. So you can consider this UPS example or health problems or whatever it may be. So in the availability, we have 4 sub steps: fault detection, recovery preparation and repair, recovery reintroduction, prevention. Okay. Next, after availability, next quality attribute is modifiability. Already you know the meaning of modifiability. The ability to make changes in the system without any side effects. You call it as modifiability. Being a software engineer, already you might have modified a number of programs. For example, if you change one variable, If we change one variable, it may be making some changes in unwanted areas. That should be prevented. That should be prevented. You see, what are the changes you require? Changes are common for any software. Already we have discussed it. So you need to implement some change, some control, some tactics to control the modifications, and changes made are tested and deployed within the time budget without any side effects. You must be in a position to make the changes with minimal efforts, with ease, without any side effects. So in the modifiability, there are three sub steps: localized changes, prevention of ripple effects, differ binding times. First, you consider localized change. So localized change means whatever the changes we are going to make, that the changes must be restricted within that area only. You call it as localization of changes, that should not impact in the unnecessary areas. For that, they follow semantic coherence, anticipated expected changes, generalized modules, limited possible options, abstract common services. Just you remember object oriented programming. In the OOPS, what you are doing? We are using the modular structures, class object model. So whatever the changes you made in one class, the changes are restricted within that class only. It does not affect the change, it does not affect the elements in another class. You call it as modularization. That means you are localizing the changes. The main strength of OOPS is data protection. Already you might have studied characteristics of OOPS, protection to the data. Okay. Next one is prevention of ripple effects. Ripple effects means whatever the changes you made at one location, it may have multiple consequent effects in some other areas. The changes made at one location may have multiple consequent effects in some other areas. That should be prevented. That should be prevented. So you hide the information, maintenance of the existing infrastructure, restrict the communication, avoid unnecessary links. Better again, oops is the best way to handle the ripple effects. Next one is differ binding time, runtime registration, configuration of files, polymorphism, component replacement, adherence to defined protocols. So you need to make these changes according to the budget. That means the changes must satisfy the time constraints as well as deployment conditions, especially cost condition also. You should make the changes within the budget, within the time. Next one is performance. So you know performance. Performance means in what time, with what cost, with what accuracy you are getting the results. You call it as performance. Always end user wants to have better performance. To achieve this performance, there are some constraints. So whatever the events we are occurring, we need to implement some performance controlling techniques. Performance means you should get the response within the time with the specified quality levels within the budget. To get this performance, there are some sub tactics: resource demand, resource management, resource arbitration. Resource plays very important role. What are the resources in your computers? Processor speed, RAM, hard disk, board, networking capacity. All these things comes under resources of your system. So you come to the resource demand. What are the resource you require to support your performance requirements? If you want to have high performance, you need to have high capacity of the resources. Just you consider, just a small example, just you consider your laptop. Your laptop is having only 4 GB RAM. Okay, for your normal programming language, maybe Java, Python programming, you are able to work. But when you want to work with data science, or when you want to play games with multimedia with much more graphic effects, automatically you will make a complaint, sir, my system performance is degenerated, my system performance is not up to the mark. Immediately what will be the my suggestion? Okay, better increase your RAM capacity from 4 GB, make it as 12 GB or make it as 16 GB. Instead of normal hard disk, go for SSD hard disk or MI2 hard disk. Like that I will give the suggestions. So you increase your performance. That means you are that performance demands for additional resources. Okay, resource for demand, increase the computation efficiency, reduce the computational overhead, unnecessary files has to be removed, manage the event rate, control the frequency of sampling, avoid unnecessary activities, remove unnecessary files. Along with increasing the hardware and everything, we suggest you to remove unnecessary files, temporary files, unnecessary apps to be removed. Even you are doing the same thing in your mobiles. If your mobile got slowed down, instead of increasing the RAM and everything, what you are doing, you are uninstalling the unnecessary apps. You are uninstalling the unnecessary apps. Automatically you feel better performance. Okay, next one is resource management. How to manage the resource? So you need to balance the acquired resource with the required resource. Whatever the resource you are having and whatever the requirements you want, both the things should be matched, both the things should be balanced in proper manner. That is called as resource management. So concurrency controlling, multiple copies, increase the availability of the resource. You know, the concurrency, the ability to access the same data at a time by multiple users at a time, you call it as concurrency. These are called as resource management techniques. Next one is resource arbitration, scheduling policy. When you are unable to use the resource simultaneously, what the next thing is serialization. For that serialization, you allocate it one after another one. You call it as scheduling policy. Okay. So by using these performance tactics, they are able to increase the performance of the system, that may be software wise as well as hardware wise. So response generated within the time, within the constraint. Constraint means condition. Along with time, what are other constraint? Budget constraint. Main thing is budget constraint. Next, after performance, next one is security tactics. Already you are familiar with this security. Security means protecting the system from unauthorized users and unauthorized access. Already you know the security features of your mobile, security of your laptop, etc. So whenever there is a possibility of attacks, you need to implement some tactics to control that attacks. So you need to protect your system, fault-proof system. So for the security, there are three sub-tactics. Resisting the attacks. First one is try to prevent the attacks. Prevention is better than repair. Prevention is better than cure. So first thing, they try to resist the attacks. They try to control the attacks. Next one is they try to detect the attacks. Intrusion attacks. Intrusion attacks. An attack came from outside of the organization. You call it as intrusion. Next one is recovering from the attacks. Once you came to know that your system has been hacked or attacked, you don't let it down like that. We use some methods to recover the system, to restore the system. You call it as restoration and identification. So first come to the resisting attacks. How to resist the attacks? So you use the user IDs, passwords, authorized users only, confidentiality, integrity, like that we use. Next one is detecting the attacks. So when your system is not behaving accordingly, then you feel that there is a chance of misuse, there is a chance of attacks. So intrusion detection systems they use. Next one is once you came to know that your system has been attacked, we use some other techniques to come out of those attacks. You call it as a restoration or identification. Next one is testability tactics. The ability to test the correctness of the system is called as testability. Input, managing the input outputs and internal monitoring. So already you are clear about testing. Next one, usability. How the user feels to use the system. If the user feels convenient to use the system, it is called as user friendly systems. To make the system more user friendly, we consider these three tactics. Consider separate user interface, you support user initiative, and support system initiative. Simply you can call it as every user has their own user ID, so they feel priority, they feel comfort. Next, support initiative, user initiative, communicate with the user, so cancel, undo, aggregate option, etc. Next, support system initiative, user model, system model should be considered. That's all.